Chapter 1 is a onslaught of definitions that you will see throughout the semester for statistics. Section 1 basically outlines the process of statistical thinking, and that will basically outline the run of the semester. So we will start the semester with the idea of statistics preparation. In the prepare stage, we look mainly for the context of the data, the source of the data, and the sampling method. That basically means what does the data represent, what's the goal of the study, what sources are we getting the data from? Is it a census? Is it a poll? Is it a random sampling? Is it a questionnaire? Which basically leads us to our next step, which is analyzing the data. Which means basically we're going to graph the data, see if we can visually grasp any ideas about the population we're trying to explore. Exploration of the data, diving numerically deep into the numbers and seeing if we can dilute any information, and applying methods with technology, using the TI-84 calculator or many online applets. And the final stage of the statistical thinking is the conclusion. So in the conclusion stage, we basically look for, is the data we collected significant to make a judgment call? So for example, getting 98 out of 100 people to fall in this one category would be considered statistically significant, whereas getting only 48 or 50 out of 100 people who fall into the same category, that would not be statistically significant. So the two steps that have most of the error would probably be in the preparation and the conclusion stage. There's a lot of problems with the sampling method, for example. People have biased opinions, so their sampling turns out to be biased somehow. So it's very important to select methods that would reduce the statistician's opinion on the matter. And in the conclusion stage, there's a lot of problems with people misunderstanding correlation and causation. Correlation basically is there's a shown relationship between two variables, but that doesn't necessarily mean that one variable causes an effect in the other variable. So it's very important to remember that correlation and causation are two different things, and they don't affect one another. Section 2 for Chapter 1 goes into the different ideas of different types of data. The first description they give us is the difference between a parameter and a statistic. A parameter is basically a numerical value that is used to describe an entire population, when a statistic is used to describe, or a numerical value to describe a sample of the population. So a census of the U.S. population would be a parameter, whereas a sample of Berks County, that would be a statistic. Quantitative data versus categorical data. These are two different types of data. Quantitative is data that can be represented numerically, whereas categorical is data that can be represented using only labels. And there's discrete and continuous types of data. Discrete is the best way I can explain this is discrete variables have integer values, where continuous doesn't necessarily have integer values. Discrete samples would be, or shoe sizes. Shoe sizes go from 4, 5, 6, 7, 8, 9, 10, whereas continuous would be the actual length of a human foot. There's only 15 actual shoe sizes, but there's an infinite number of actual size of human feet. So the shoe sizes would be discrete, whereas the length of a foot would be continuous. While we collect all this data, there's going to be different types of level of measurement. The first level would be ratio. That basically means there is a true zero measurement. For example, heights, lengths of objects, distances, all those have a definite zero beginning point. Whereas the next level of measurement, interval, does not have a true beginning point. For example, temperature of outside in degrees. There is a 0 degrees, but there's many temperatures below 0 and above 0. So there's no true starting value for temperature. So that would be an interval measurement. Ordinal measurement is when you can arrange the data points in rank or in order. And last but not least is nominal, where you can, the measurements of data are basically labels, so eye colors or positions on a football team. Section 3 goes into detail about the different types of collecting and sampling data. It talks about the sampling methods, which is simple random, which is straightforward. Systematic, that basically is you're collecting data and you're going to choose every 5th or 7th person. It's a numerical value. Convenience, exactly how it sounds. The sampler collects data based on where it's convenient for him or her. Stratified or cluster is where a lot of confusion happens because they are both sampling certain groups. Stratified is when you break a population into groups based off a characteristic. So for example, breaking Pennsylvania into men versus women. That would be a stratified sample. So you would break Pennsylvania into men and women and randomly sample within those two groups. Cluster, you're not breaking the population into groups for a characteristic. You're breaking them off into groups based on, for example, location. So a cluster sample would be breaking Pennsylvania into counties, then randomly sampling within each county. In this section, they talk about the difference between an experiment and an observational. There's different types of observational studies. Observational studies basically mean you're not performing a specific action on any sample. You're just observing the characters. The first type is cross-sectional, which means the data is collected at one point in time and one point in time only. Retrospective means you're going to be referencing the past, so you're taking a bunch of data sets and you're looking into what they did or did not do in the past period of time. And there's prospective, where you break the population into groups and you observe what they do in the future. And to wrap up section 3, they talk about different types of sampling error. First type is just it's pure chance. You collect data on a sample and it just does not look right. There's a chance that it was just a unlucky sample, and you should probably choose or do some more samples. The bigger the sample, the more likely it's going to be accurate. There's a non-sampling error. This is purely human error. So if you collect your data but you inputted the data into your spreadsheet incorrectly, misspelled words, that kind of thing. And then there's the non-random sampling error, where you chose a sampling method that was not random and it was selective in a biased way.